So hey guys, hello everyone, good evening all, good evening. Just hello. Can you all hear me and see me clearly? Guys, hello, hello Rahul, Vicky, Khushi. Am I audible guys? Let me check my mic. Yeah. Hello. People, am I audible? Hello guys. Am I audible? Yeah. So just give thumbs up in the chat box that am I audible and visible clearly? Hello. Guys, put some emoji in the chat box if I'm clearly audible. Hi Manshu. Hi Farah. Hi. Yeah. So guys, I welcome you. So first of all, I will introduce myself. So myself Anam from LetsUpgrade, and I welcome you all for the Netflix project building that is for 2 hours. And yeah, thank you guys. So guys, just wanted to inform you that we have done small change in this project. Like instead of 2 days, now we will complete this Netflix project in 2 hours, or might it extend for 10-20 minutes, not more than that, I hope so. So guys, be with us for this 2 hour session. And till then, please like the session, please do like the session, comment in the chat box, sorry, put some emojis in the chat box, and do like the video. Also share with your friends. So guys, let's and for our trainer for today is Gaurav Dip sir. Many of them must be knowing, so I will just share my screen and tell you some info like about docs that we have in our description box. Guys, my is my screen visible? Hello. Guys, is my screen is visible? Just tell me yes or yes. Certificate will be provided after the session. When the session will end, you will get just mark your attendance and reload your page. You will get the certificate in the same link where you will mark your attendance. Okay. So guys, here in the description box we have one link, doc link, where everything is in one place. So from here you can mark your attendance, you can refer your notes, and like you will get the session link also, and step by step process is also there, like how to mark your attendance and sign up in the Let's Upgrade portal. Also guys, here in the notes you can see all the notes. You can refer this, you can save this link somewhere, so that you can access it anytime you need it. Guys, please don't spam in the chat box. Just put some hi, hello, attendance link. I will share everything here in the description box. We have attendance link also. So everything is there in the description box, and certificate will be available after 8 or 8:30. Yeah, so I will introduce Gaurav Deep sir to you all. So
All
hi
right.
sir.
Hi,
How are you
ma'am.
sir?
All good. All good.
So, sir, just you can tell something about this project to our students, like what all things we are going to cover, how you will teach them, and uh, yeah,
Sure. The project that we are doing today is building a recommendation system. Now, the idea and inspiration comes from OTT platforms like Amazon Prime, Netflix. So, we will try to build something based upon Netflix dataset. We will learn different types of recommendation systems, how to make them, and we'll do hands-on, of course, on the Netflix dataset, where I'll be using a cosine similarity model to explain you how, based upon one input, you can produce the output. So the main idea, the entire goal of this live session is that you all, by the end of the session, should have some insights about how recommendation engines work and how we can make something similar to a Netflix recommendation system.
yeah. All right. Okay, sir. Thank you. So, I hope this session goes smooth and everyone will coordinate and be with us till 2 hours. Okay, sir. I will hand over the session to you and I will leave. So, bye, guys. Bye, everyone.
Sure. Okay. Thank you so
Have a
much.
nice time.
So First of all, hi to everyone. I see that we have more than 100, 140, around 150 people streaming around from different places. Uh, the goal is pretty common. We all have a single agenda that today, if we all have taken this time, we have dedicated the next 2 hours. It is only with a sole purpose agreed to understand recommendation systems and be able to work around them. Now, with that, I'd like to congratulate all of you that you have already taken the first step of joining the session. Now, it is my responsibility that the next few hours turn out to be fruitful for especially people looking out to make career in data science, machine learning, AI field. Uh, Maybe people who are good with statistics, people who have background with IT, non-IT background people, anyone who is interested in this domain, I'll make sure that you take something out of this session today. Now, before I begin, let me give you a very brief, short introduction about what do I do, what is my way of earning the daily bread, or what exactly is working in life of an ML engineer. That is probably what I'm doing. So currently, I am mostly involved in a senior software engineering role, which involves knowledge of maybe a full stack developer. You can say that you need to understand some deployment phases, machine learning ops, ML ops, DevOps. You need to understand backend, front end, how these technologies are integrated. Work around with people from different programming regimes like Node.js, JavaScript. You can say maybe Django developers for Python, uh, Vue.js for front end, Node.js, and many different technologies that we use to create an app, to create a website, and then primarily also lead the role of making machine learning models. We play around with a lot of cutting edge technologies, working especially with large language models, the generative AI, stable diffusion models, to use the Gen AI for building many interesting client and industry based solutions. Now, apart from that, if I talk about my qualification and background, I started my career as a non-IT guy, trying to struggle and join, you can say, the flow or the force, which was the data science regime, which is where I found my interest into the field of artificial intelligence, AI, and I primarily focused on building my skills into mathematics, statistics. Luckily, being a mechanical engineer, I had good mathematical background. Learning a programming language like Python, moving ahead with it, understanding how the IT infrastructure works, how does a computer work in short. So, with this being the center of focus I had, finally I have matured and developed as a machine learning engineer, and I specialize in making solutions with machine learning technologies and AI. Now, when we talk about the concept of artificial intelligence, it is again something which is inspired from the human brain, the natural or the intelligence created by someone. So I always like to introduce AI with the concept of the edge of the science and also the unknown, uncharted domains and boundaries, like maybe with the existence of supernatural powers, like maybe a god. So artificial intelligence begins their concept with that we need to make something which is much more intelligent than what humans currently are. Now, what is the one big problem that humans face or have is that we all have memory leakage, right? Or maybe not I'll not say memory leakage, but memory limitations. The computation power that we can hold in our live brain is not as capable as a RAM of a computer or a CPU can do. So with this, certain mundane tasks like adding few integers, which can be done by a human but will take a lot of time if the calculations are complex, are very much achievable by the computer or the CPU, to say that. So artificial intelligence builds around the concept that how a human brain works around with the neurons. We inspire something like perceptron. So it is as simple as, suppose that if I want to create any invention, I have to innovate something. Maybe like I want to create an aeroplane, I want to create a helicopter, I want to create something as simple as a fan or an air conditioner. I first try to imagine how the components can work, right? In my designing phase, I try to build a prototype. So as much as knowledge humans have about how human brain is supposed to work, the natural brain, the natural intelligence, we understand that it has neurons, and neurons trigger in different ways to perform different tasks. So the idea is to build perceptron. And to build all of this is nothing but AI. Now, again, I will limit the definition or foundation of AI over here. If you all are interested to understand the foundation of artificial intelligence, we can definitely have a live session on that. And you can always request Let's Upgrade for such interesting and more sessions for you guys, where we will only talk about how AI came into existence or the complete concept of it. Now, moving around with the data science, how data science works. So, data science is not something which is an innovation of today's generation, right? Data science plays major role even before pre-independence era, right? Even let's go back to Harappa civilizations or Mohenjo-daro or wherever you want to take it, right? Egyptians during the time of they were building pyramids, statistics, mathematics has always existed, right? And the the nations how they used to work, the kings had a department of statisticians who used to plan the finances and things. So data science even today works in the same fashion. We are still using statistics to find mean median mode, to find the central tendency, to predict, to understand or to forecast, right? In the same concept, the things have evolved. Now, rather than having a stone or a chalk or a paper or a pen, we have computers and we have tools which are hard coded to understand statistics, which are developed in a way that statisticians can now more conveniently and in a say more efficient manner make more detailed explorations. We have tools like Tableau. We have tools such as Python programming languages and R programming languages with built-in libraries to support statistics, right? And visualization tools which can quickly draw things for us. We don't need any more scale, paper, pen to visualize, right? Or neither do we need to know any graphical knowledge so that we can create graphs. It is all automated now. So that is the concept of data science, where the old statistical approaches or the existed approaches have been digitalized or computerized in a way that now they are more efficient. And when we say that we are entering the age of data, which we are already are, uh, we definitely can say that in this point, the data has boomed so much that we will always need things like Tableau or the concept of data science always to be handy. Let me just quickly present my screen. I'll share it. Okay. Now I'll just assume and you all can put it in the chat if the assumption is not clear that how do you start a Jupyter notebook. You can please let me know if you have any difficulties with it, right? Now I have created a new notebook. I've named it anything that I thought I should, and here we are. You will need specifically some data to play around with it. So let me just quickly look into the description if there is any data attachment for it. Assignments, attendance, registration, full link. Okay, all right. So I'll also request the moderator to pin the dataset, the Kaggle link, which I might have shared over here, or let me also try to share it in the chat if possible. Okay. So, Jayesh, the idea is we can always try it in VS Code. We can always do it. By the way, the link is here. You guys can use it. Uh, yeah, you can try anything you want. See, again, as a fresher or as someone who is based upon some editor as a preference, I would like to add this, that take it as a hard way that you will have to at some point break away the dependency on one IDE. So to make it clear, I do not like Jupyter Notebook at all. I prefer the VS Code or maybe the PyCharm, right? But the idea is that For certain things, certain IDs have benefits, right? For example, when it comes to a zoom lens, only there you can say a Samsung S23 or S24 Ultra have a benefit. When it comes to portrait, maybe I'll switch to iPhone. So similarly, when it comes to personal choices or personal preferences or certain pros and cons, these Jupyter notebooks are very much suited for the task that we are currently trying to do. It is a demonstration of something. There is a clean background, and the way it is arranged is good for presentations. VS Code, I'll choose it when I'm developing something. And of course, any ID it could be. The idea is just to write the code, right? So you can follow the same thing that I'm doing right now in this notebook in the VS Code itself. In fact, VS Code itself has an extension of notebooks. You can just simply convert your .py file to ipynb, and if you have the notebook installed in the VS Code extension, you can also open Jupyter notebooks in the VS Code itself. Yeah. So, all right. Yeah, you can use whatever you want, collab, Jupyter notebook, anything, right? It is as simple as someone is using Microsoft Word or someone wants to use the Google Docs, right? So moving ahead with it. First, let us try to understand what exactly is a recommendation system. Now, I would like to keep this live lecture a little less boring, right? Because usually when we try to switch into any YouTube video or any lecture that you want to learn, there are many prerequisites which are so boring that we would like to fast forward for 6 minutes. You already know what recommendation systems are. But we always forget one thing in this fact is that some people might have the tendency to get completeness. The satisfaction of having a lecture with the completeness makes it much more wholesome. So I will make sure that I balance out the audience in a way that I will not talk about recommendation systems theory for 10 minutes. I'll just walk you around what recommendation systems are. And it is bare basic, right? It is to suggest something that the user might like. One single liner, right? It could be now movies, it could be music, it could be some products, maybe your daily needs. And there are different ways to look into it, right? Maybe like suppose if I'm going to a grocery, I want maybe I'm going to a store, a grocery store, I'm buying bread. You will not like to recommend me a mobile charger if I'm buying bread, right? With it, you would go for butter or maybe for eggs or maybe for milk, the more possible things that I can buy, right? So that's something that you should look into. Again, building such systems is all about using your brain first. Okay. See, the idea of having innovation is all about how intelligent a human can think, right? Rather than depending upon the theory. Depending upon theory, innovations never happen. You have to break something by using the existing theory. So similarly, if I say this is how you build recommendation systems, it is just the way some problems have been solved. Using that, maybe you can use your own brain. I'll give you some examples. Suppose that uh, if I have to build a recommendation system for someone that they can buy different vegetables, or I have a grocery store, vegetable store, I might try to analyze what recipes this someone trying to make. Suppose if someone is trying to make palak, now I can remember some Hindi terms that we have sarso, we have batua, methi, even like that, many more leaves, right? Like these are some leafy vegetables I'm talking about. So the idea is if I'm able to catch this, that you are buying maybe like the spinach leaves, you're buying the, you can say, reddish leaves or things like that. I can try to understand what uh, recipe you're trying to make. And I can give you a bundle of that recipe as a recommendation system, right? More likely the user will buy it from me, the bundle system. So this doesn't use any hard and fast rule. It uses your intelligence, right, to make it to solve it in a way. And this is not pure theory. This is, you can say, a jugad, or you can say a strategy that locally works for this particular recommendation system. So understand the goal or the idea is that a recommendation system is all about suggesting items which the user is more likely to buy now. Okay, which is why you will always see no mobile store will go without mobile phone accessories. In fact, like I can't remember the last time I bought a new phone. I didn't buy the back cover or the glass, the protection screen, or accessories from the same shop. For example, I recently changed my phone, and nowadays phone don't come with a charger, so I bought the charger from the same shop. So such accessories which can definitely have a heavy weightage, how to design your inventory, how to uh, play around with the inventory. If you are aware with the theory of ABC of inventories, A is something like a running item, right? If I again stick to the grocery market, maybe onions, tomatoes are something which the person can buy without worry, even 5 or 6 days of stock in advance, because they know it is going to sell off. But when it comes to some exotic vegetables, like maybe some exotic fruits like dragon fruit, or maybe something like the bell peppers like yellow or red bell pepper or broccoli, or things which are not common in our market, the regular buyers, they will like to stock it in lesser quantities, right? C would be really rare things, right, which sell very rare. So they can help you plan many things, the recommendation system, right? And I'm pretty sure that the things that I'm sharing with you are definitely giving you some insight of how you can improve the customer satisfaction engagement. You can discover basically some new rules of consumption in your business. You can plan your inventories equivalently. So any new channel platforms, media platforms like Netflix that we are trying to build today, or any such consumption platforms, e-commerce platforms like Flipkart, Amazon, or anything that sells you products can definitely benefit and have a much better response or result if it is based upon any recommendation AI or system, right? So the recommendation system that we are trying to build it today is rule based. So when I say rule based, I simply mean that we will be purely using mathematics to do it. Okay, so do it on VS Code for the beginners. It will be easy. Probably not exactly. I do not. I will not completely. In fact, like I'll only partially agree with you. VS Code will not be more suitable for common audience. That's what I strictly believe. And the alternate downside is that currently the laptop that I am using is been borrowed from someone. It didn't even have Python installed. Even so, like just 45 minutes before the lecture, I have made sure that the Jupyter will work for me. In fact, like just let me once again try to print hello over here and confirm that things are working fine. Yeah. So we will stick to it. And VS Code people can definitely work in that. And I'm pretty sure if you know VS Code, you are good with Python a little bit. Okay. All right. So now the data link has been provided to you in the chat again and again. And the moderators can keep on pinning it. The Netflix resource is available to all of you. You can just quickly look into it, and we will just download the Netflix resource from there. It is less than 1 MB, shouldn't be a lot of burden to download it. And once you're done, we will be right over here. Now we will talk about the type of recommendation systems that exist in the market, or at least let us say, as far as theory is concerned, few of the most common ones. The one is known as content based filtering. What does this mean is that we try to find something similar that the user liked in the past, okay, and maybe it has some rule based approaches to do it. So you already know that we are now trying to build something like content based. We can use different features like the actors, the directors, the cast, the crew, the certain keywords, genres, or the classes they belong to, right, to map it. So content base is always based upon, maybe suppose if I'm watching a horror movie, I'm watching say Annabelle, okay, and I'm interested in that movie, maybe I can recommend you The Nun, right? Both are horror movies and they play around that way. I can further try to improvise my content based filtering even by merging multiple parameters to compare. Not just maybe the genre. I can also go for the cast comparison, or the actor comparison, or the theme comparison. Maybe the Annabelle is a doll, a possessed doll. the nun is not about the possessed doll, but maybe there are more pictures upon the doll possession or the possession. I can also try to capture that meaning and try to match it with a rule, that try to find this theme similarity. I can go for directors. Maybe I have a personal director. If I like that person, sometimes I'll also try to watch movies for actors which I don't like because I trust the director. That if this director is making something, maybe there's a chance the movie would be good. So there are different rules that you can approach, apply, combine, play out, and build something known as a content-based recommendation system. The next one would be the collaborative filtering. The collaborative filtering in itself means collaboration, right? Well, what is this collaboration which is happening over here? The collaboration is that we will, okay, just let me just quickly look into the chat. There are a lot of chats happening here. Yes, okay, I'll definitely give the complete code. We can use English, of course, that doesn't bite. Yes. Okay. Uh, Chavi, I will specifically prefer if you stick to the VS Code. If you have, that's not a problem. Stick to the VS Code. It will work out for you. Okay. Yep. Uh, all right, all right, all right. That's great. Perfect. Now, moving ahead, what I will say is the collaborative filtering, how it is supposed to work is we take, say, now how do we decide the size of this collaboration is something again like it would be a hyperparameter. I'll take 10 people, 20 people, 100 people, depending on on the bandwidth or the data set that I have, will also play a role over here. Suppose if today 1,000 people have booked a ticket to watch a movie, okay, could be say maybe Pathan, which is a movie. I think it belongs to this some the universe of something, right? Yash Raj universe. I'm not sure. But if you are watching that movie, I will assume that these people who watched Pathan, uh, they might also be interested in watching uh, the Tiger 3, right? Why? Because the mass movement shows that. I'll give you an example. Suppose I, as a person, I, as Gaurav, goes to watch Pathan, okay, which is a movie came up recently, and 1,000 people like me also watched Pathan, okay. Now we fast forward, we have built a trained a model like this. Now this model will understand that all these 1,000 people, along with Gaurav Deep or Gaurav, went to watch Tiger 3. Now, since this group or this cluster is moving together, they will try to recommend me that you will like Tiger 3, and I might like it because I like that universe. So someone who's interested in Rohit Shetty films, right, which belongs to Ajay Devgan and other actors, I might not be able to remember the name of all, but if that is there, they might like all that. Simba, I think, yes, Simba is the movie name. So people who have watched that Cop universe, any coming movie in the cop universe, they will like it. And wherever this cluster is moving, those points will be recommended to you because you belong to that group now. Okay, so grouping is known as like a collaboration filtering, where we group similar people and what the people, how the people are interacting with the environment, we give you those recommendations. Now, trust me, in real life, if you have to make something which is industry standard or really robust, would definitely follow both the approaches. Netflix has released a statistics that 75% of the audience uses recommendation. They don't whenever they switch on Netflix, they don't know what to watch. Recommendation works for them. So it is known as hybrid filtering or hybrid recommendation systems, which combines the advantages of both collaborative and you can say content-based filtering. So again, how let us now switch to how you can actually make something like this. So the first thing you will need, the most essential thing would be the engine or the heart of it would be the data, right? So data is collected over time with a lot of efforts. uh, Money is involved, time is involved, uh, a lot of hard work is involved in collecting this data, right? You cannot just simply give 100 rupees to everyone and open a Google form and tell them please put in your favorite movies and this is how I'm collecting data. That collected data has to go through scrutiny, right? Maybe today, if you're telling me you are giving me 100 rupees to fill out a Google form, which will take 2 3 minutes, I might just fill in some garbage, right? Because I don't care. I will just click randomly everywhere. submit. The data is gone, but money is wasted because it's a garbage data. So even after collection of data, there is a lot of scrutiny. The data, you can say the data cleaning or the data processing task. We have to get away from the redundant values. Uh, See how the digital world works is sometimes we have to convert things from maybe XML or JSON to say Excel sheet, Excel to Google Sheets, maybe put it in some database, convert it, encode it, decode it, move it 100 places. Maybe in this process some points get corrupt, maybe some points were not collected if the data collection was manual, right? See how this jan ganana, or you can say how we do the counting of the population. It totally depends upon reaching out physically door to door, right? So we could have some missing values. Suppose if mostly in this manual collection task, there could be many missing values if the things are not based upon rule, right? So you can create rules that do not accept a form if there is a missing value, or warn your user that this is the missing. Until unless you provide it, we will not proceed. So that's how missing values can come into picture. Outliers can come into picture if your forms are not correctly coded and there is a leak or say a bug into it. Suppose you're asking me for my height, okay, and suppose if I rather than entering 645 enter say 185 188 centimeters, but I'm entering 188. Your input is foot. So what will happen is that 188 foot cannot be the input, right? So until unless these discrepancies are there, you might have outliers. You might have redundant or say garbage data inconsistencies, right? I can maybe I can write my. You were asking me for my age and salary. So in the age, if I put my salary, in the salary, if I put my age, see how disastrous the data could look like then. So the main task, or I'll say 70% of the effort goes into the data cleaning, data preparation task, which is why there is always a never ending demand of data analysts in the market. And data analysts are needed everywhere, right? So it is like, I would like to say data analysts are like potatoes. Because there is no recipe or a very rare recipes where I would see potatoes cannot fit, right? But other vegetables, they are specialized. So if you are an machine learning engineer, if you are a data engineer, or if you are into any other regime, your data scientist or maybe business analyst, they all will always need a data analyst. They will need it. Okay. So a company will always rely on them. So which is where I'll say 70%, 60% of the efforts of having a good model is here. Once this task is done, the next task is model selection, training, and evaluation. So again, splitting your data, cleaning it, validating it, choosing a model, using it to perform, working on some matrices like say recall, precision, root mean squared error, whatever you're solving, fine-tuning your hyperparameters. It plays a major role, and then deploying it and monitoring it, and then continuous learning, which is a technique in machine learning, which is known as that. Today I have say 1,000 data points. I will create a model. I will try my best to optimize the parameters based upon whatever I have. I'll deploy it. Go into the market, let this model play. This model will get more data, and as and as the data grows, I'll keep on retraining it, fine tuning it. Every week I fine tune, every week I fine tune. So over time, my model becomes robust and industry ready. So these are certain approaches that we can have. We could recommendation systems. What are the challenges that we can have? The challenges could be always you will have a cold start, especially for things you're trying to recommend which are not easily solvable. When I say cold start, your initial recommendations will be haywire. You will be recommending north and south to people, right? But over time, when you expand, you scale, you personalize, the data grows, this cold start problem will disappear, right? So resources are needed a lot to create something like this. Now you all have the resource link. Let me just try to quickly check where is my notebook firing. OS dot get CWD. Okay. So the idea is, students, what I'm doing is this is not part of the code. What I've done on the notebook right now. This is just to check from where is my notebook firing. Okay. So operating system OS. OS is a library which can interact with your operating system, in short, OS. Now, this function tells you where exactly is this code running from. So in the C drive, in the folder users, there is a user by the name of Jasbir Kaur, and in that folder is where the system is running from right now. Okay. So I will make sure that the zip file that I am recently going to download, I place it in the correct place. Now you all can just quickly go through this process, understand where you have to put the file. For me, it is users just be for. Okay, so I'll extract the file quickly, and I'll recommend you all can do it same. Uh, you can just check the dataset is continuously being provided in the chats. Okay, so we will make sure that no one is left without the dataset. I'll just quickly do it. See users just be for. This is where I should be able to find things. Okay. I'll also now quickly try to do os dot list directory, and if I use this command, so basically what list directory will do for me is it will give me a list of things in the directory. So if I look, I can see Netflix dataset is right over here. I can confirm this way also that I have placed the dataset in the correct location, right? So things are all good for me, right? So the G9 Gaming, you have recently joined the channel or the live. So currently there is a link right two chats above you. You can download the dataset from there, and we are just going to load it. We have covered some fundamentals of what a recommendation system is supposed to be, and now we are at a point where we are trying to load the dataset, and we will look into it now. All right, great. So I'll just remove this. The idea was just to make sure that you guys understand where am I and where the data set is. Okay. Now we will import some basic libraries like NumPy is used for internal computations, right? It is a very good mathematical library. Okay. Pandas, you all must be aware that this is like the Excel for us, right? Whatever the Microsoft Excel or the sheets can do, Pandas is much more efficient in handling the two-dimensional data, right? Something known as data frame. So sklearn is your magical library. It is the, you can say, the magic wand of machine learning, where all the supervised and supervised techniques can rely, right? Until unless you're talking about deep learning, sklearn can play magic for you, right? So there is a method known as feature extraction inside sklearn. That is what we will import. Okay. Now remember, yes, so where you will get this whole code, I'll definitely give it to you. You can try to make it right now with me, and you will always have this code available through some location. I'll make sure that I provide it to you. Okay. Now, before we move ahead, let me just make sure that we are all on the same page. NumPy, pandas, and remember, students who are not sure why do we add dots while importing something. So, if you are aware what functions are in a programming language, so I'll just quickly guide you that suppose if I create any program and I name it something. If you realize that this notebook that I'm creating, the name of the notebook is recommendation Netflix, right? This is the name of the notebook. So similarly, someone who created NumPy actually named the file name as NumPy. Someone who created pandas named the file name as pandas, right? So similarly, inside a file, if there is one particular function that I want, I do not want to load the complete file, but just a particular function. So that dot is used to refer the function in that file. That from sklearn. Sklearn is a very huge file, right? Uh, I only want to import feature extraction, and from feature extraction file, I'll more specifically import only text. So this is what this things mean, right? So of course, if you are learning Python from Let's Upgrade, I'll make sure that during those sessions we try to use hours and hours of effort to give you all these bare basic details, even walk you through these details of how these imports work, but I'll make sure that I justify to you all in this time space also, that whatever I'm talking about, it is making sense, right? So sklearn is a module. Dot matrix is a submodule. Inside module is a matrix known as pairwise. Okay. So in pairwise, there is a function known as cosine similarity. So okay, this is this we use to recommend. Okay, I told you the kind of system that we are making today is, again, it is based upon what? Is it collaborative or is it content based? We are going for content based. And there are different models that can be used for content based. I told you cosine similarity could be one, Jacquard similarity could be one. What are exactly cosine and Jacquard similarity? They are nothing but NLP toolkits, libraries, or say mathematical concepts where we map text to text. It is text based mapping, right? Finding similarity. For example, FAIR, fair, okay, and FAER will have more similar score because F, A, and R are common in them, right? Compared to, I'll say, fair and XYZW. It will have least similar score. Okay. So that's how the cosine similarity works. Similarity works in short, I will say. Okay, it is all based upon the cosine angle that the vectors are making with each other. Collaborative filtering, simple unsupervised learning (KNN) is an example of how collaborative models can be made. Okay. Now moving ahead with this knowledge, I've told you what we are using, why we are using. Let me just quickly import it. If at all anyone is failing in the import, it means that certain libraries are not installed. If you look at the error, you will be able to do pip install numpy. Okay, you can also use space pandas or space sklearn to install all of them in one line. If you are using Jupyter Notebook or Collabs, you will have to use an exclamation before the pip. If you are using VS Code, without exclamation should do from the terminal. And once this is done, well and good. Okay. Okay. Yep. It shows this site can't be reached. We can't use high pace. That's not everyone. Okay. All right. No worries. If Jupyter Notebook is not downloading, you can use Google Colab. If you are not familiar with Google Colab or you are using VS Code, stick to it. Okay. Let me just quickly verify if the download link should work or not. I'll just quickly open it myself from my phone, and let me give the authentication to the phone. Kaggle.com. It is working fine for me at least. Not sure why you are not able to access the link. Try it once again. There are multiple places where we have given this link. If you are able to open it, well and good. Okay. All right. Fine. So again, I'm not sure. Basically, let me just go back to YouTube. Okay, the link is working fine for me as well. Okay, great. All right. I'll just recommend the moderators. They have pinned the link. Okay, the link is pinned. You can go from. Now let us load this data set. Okay, let us simply say we will create a variable where we will load this data set. So pd dot read csv is the command. It was Excel file. You would have used read xlsx. Okay, or whatever you want to read. But we are using a CSV, so we will just go for it. Again, what was the name of the CSV? os dot list directory Netflix data. Okay, I'll just paste it over here. Now again, students, whenever we write read CSV, inside we put the path. The idea is to put the path where your CSV is. Currently, my CSV is exactly where from where this Jupyter notebook is running. So you can also see that my os.list directory validates that, right? That this is things that the code can readily read, right? Downloads, documents, things like that. Netflix database, and even this notebook is right lying right over there, right? But if for you the path is different, you can just simply copy the entire path. Use if you're using say Linux, Ubuntu, wherever you are, you can just do right click properties, copy the entire path and paste it over here, right? The entire path could be something like this. I'm just trying to mimic it. C users or wherever it is, right? It could be anywhere. D drive, F drive, G drive, wherever it is. We paste the path basically, and let me try to print the head of this data. So head is again nothing but it is a feature of pandas itself, where we will be able to print first few lines. Okay, in the head, if you put 10, 100, 20, this is the parameter that is optional, which will tell pandas how many lines you want to print. By default it takes 5. Okay, so you see 0, 1, 2, 3, 4 is something by default it takes. Again, the lecture is not about Python, else I would have definitely told you or showed you how you can customize and visualize such Excel sheets or CSV sheets which are big enough. But for now, you can look over here. We have show ID. We have movies, descriptions, directors, genres, country, cast, production. I can see nans coming into picture. I can see many things happening. In fact, like if I try to look into the movie names, there is again some anomaly, like hashtags should not be something which is included in the name of the movie, right? So header function gives us this insight, and as I told you, you can use whatever you want. If you just need 3 rows, use header 0, 1, 2. That's it. Okay. If you need maybe 10 rows, use this header 0, 1, 2 till 9. Okay, that's how you can play around with it, but that's not the goal of today's session. I'll leave it as it is, the head. Okay, please explain the lines from very basic keyword like object method function. All right. Yeah, I think I have explained to you all that what SK11 feature extraction in this file would mean. You can just anytime revisit, look into it. Okay, and always I recommend that Let's Upgrade always have sessions related to Python. You can be always open to those sessions. Okay, so now the idea is that there is a lot of things which are missing in the data set, right? Many things which are not working, or the data is not at all clean. That's what something we can see, right? So we will have to print something like print data is our variable name. Since it is a pandas data frame, all the data frame features will work on it. So dot is null is a data frame feature. If I just run it, it shows me like true and false, right? But if I use one more function in front of it, like sum, it will, rather than showing me all the rows, just give me the count of missing values, right? So sum shows me that all these columns, director is the most missing thing that I have. Cast, country, date added on, IMDb score. These are certain values that are not exactly, you can say, a good data column to have, a good data feature to have. A lot of missing values, right? The more you extrapolate, the more you try to make it synthetic, the more you lose the natural essence of the data set, right? So what we will do is we will simply say let our data be equals to data, where we'll be using only strictly some columns, right? So we can simply go for title, we can go for description, we can go for content type, and of course something that we should not miss is the genre, right? Because that is something is the heart of this engine that we will be using for cosine similarity. So you guys can just quickly follow on this, that the data should be, uh, now we are mentioning, this is known as slicing basically in terms of Python programming or data frame if you want. Slicing is nothing but how you cut a cake. So if the entire data set is a cake, I'm just using slices of it, right? A slice which is all about titles, a slice all about descriptions, all about genres, right? Now when I do it, and when I do data dot head, ideally if you're using VS Code, this line should always be wrapped with print, okay? Because Jupyter notebooks will work without the print also. For the last line, you'll be able to see now I have title, description, content type, and genres. These are the only 4 columns now that I am interested in. Now with these columns, now let me check. Now let me repeat this code of line, which is data is null and submit to only see things that I'm interested in. Nothing will change. The output will always remain same, but only four columns. And now I do not have null basically. So that is one lazy way to look into it, but also one correct way to look into it, right? Uh, because if you see the quantity of null, at least in date added or director or cast and production country, were very huge. We could have taken rating as a factor, we could have taken duration as a factor. Of course, we could have, but it would only complicate the project more, right? We'll try to keep the things as clean as possible. Okay. Now, again, the idea is that if you see if there are any nulls at all exist, the idea would have been to drop it if there were any nulls. Okay, so on the left you are creating a variable again data. In the right you are giving its value. Okay, so you are updating the current data itself with drop NA. Okay, now if I try to print data, if I just simply print data, it will print out like this only particularly in notebooks, right? Which is why I told you notebooks have an advantage while doing data analysis. If you were in VS Code, this is the output you can expect. Okay, I'll go back to it and just restrict back on data. All right, I can see the titles are not at all clean, right? There are some titles maybe in Arabic or Urdu languages, some in Japanese languages, with some with hashtags and a lot of things working around, right? So I'll have to make sure that I restrict things, clean the titles also specifically to be only in the VS Code version. Okay. Sorry, what I'm saying is only the English version. Okay. All right. Cool. So for that, why we slice? Okay, let me just quickly check why we slice the null values. Can you explain? So the reason to slice null values is that first attempt should be to restore data as much as possible. But if your data is beyond repair, specifically like 1,000 missing values, 2,000 missing values, in a data set which is in thousands itself, right? It is not a data set in crores and lakhs of rows. So in that data, this value is impactful. And if you try to use synthetic data on a file which has already limited data points, might totally degrade your data. Okay. So the idea is to not use those files which are extremely missing, right? They are beyond repair in a one way. And of course, you can always try out if you want to, but the good strategy would be if you can afford to lose it, lose it. Okay. Now I'll talk about a few libraries that I've recently using. Right. So Prashant, if you're using OS dot list directory and you're facing an error on that, it is mostly probably because once you have to write import OS, your OS might not have been imported correctly. So you can use this term and then work with it. It should work. Okay. All right. Okay. Fine. Moving ahead, I'm using NLTK, which is say NLP library. So NLP library means it supports many NLP tasks such as stemming, lemmatization, okay, to work around with text, stop words. I'll just quickly work around with these terms then. So stop words is nothing but the garbage words in a context, right? Let us try to just quickly look into movie review that I liked Tiger 3 because acting. I didn't like Tiger 3 because the action scenes were not appealing. Okay, so in this review that I'm getting, I did not like Tiger 3 because action scenes were not appealing. The most important words would be not appealing, not like. Okay, like and appealing, and not with that. The negation with that. These are the most important terms. I has nothing to do with the sentiment. Like, did not like, these are important words, right? So all the conjunctions, the connections which happen in the sentences, they are not I, a, the, we, you, him, her. These are not important words. They are stop words, right? The garbage words which do not contribute, right? He did not like the movie, I did not like the movie, the review will still remain did not like. So uh, Those are not stop words. And usually when we clean data, especially when we talk about the NLP data, the text data, this is a mandatory step to remove the garbage so that your model will not focus more on stop words. The next thing is RE, which is known as regular expressions in short. These are specifically used that suppose if you have any rule-based, logic-based things happening in your statements or text, you can remove it just by using the logic. Suppose if I tell you that you will get data where you will have something before it and a slash will be there, and then something, and then a slash will be there, and then something with a white space. Okay, let me say WS is white space. Uh, and let me also call it white space in the start. If I create something like this, what my program will now keep in mind is that if I'm getting white space, if it is followed by something, whatever it is, I don't mind. There's a slash, something slash, and a white space. This is now a rule defined. Now, don't you see how beautifully I can create rules like this? 24, 7, 20, 23 is valid over here, right? Something like 8169 dash or slash 22 uh, 41 is not valid in this rule, right? So basically what I can do is if I give this program, in fact I can further try to make the program more robust by saying there will be integers, right? Integers followed by integers with slashes and white spaces. Remove them, delete them. So that is where regular expressions come into picture. Regular expressions are all about making or building rules which you want to remove from your statements. So to build that, we will be using regular expression library. I'll also walk you around with some regular expressions today. So NLTK dot download, I will say what do you want to download is stop words. Okay, so if you are into gaming, if you game on anything, maybe it could be like Battleground India, PUBG, or any other game that you like to play, or even if you are not a gamer, if you understand the concept that when we download a package, it comes with bare minimum things. If you want to download some theme, you want to download some particular say resources, maybe like some particular theme of the gun, maybe some particular theme of the dress, those comes as extensions, right? They do not download by itself by default. When you install any operating when you install any operating system also, or any say even if you're using downloading MS Office, it gives you something known as bare minimum installation or custom installation, where you want to download some custom things, maybe some custom language packs. Your Google, okay Google, hey Siri, or whatever you call these smart systems, they also come with language packs. Your typing keyboard comes with a language pack. Basically, it is a keyboard, but you can add extensions. So similarly, NLTK, when you install it, suppose if you do not have NLTK, it will throw you error. Again, I will remind you can use pip install NLTK to do it. People who are not using notebooks collabs, remove the slash, okay, in the terminal. So they install bare basics. Apart from that, I now need stop words capability. So I'm using NLTK download stop words as an extension tool that I'll be using, which is where after it I'll create a stemmer which is known as stemming. So remember how to remember stemming is that this word of stemming itself has something known as ing, right, in the stemming itself. So stemming tries to cut the suffix prefix like this, right? Like runner will be cut by er, it will turn to run, run or something like that. Okay, ed, ing, such extensions will be cut, and whatever is left will be the word, right? So of course it is not as robust as lemmatization, because lemmatization uses the dictionary, right? Suppose if I have a dictionary, and if you try to look into any dictionary, you will be able to look into it that every word has a adjective form, a verb form, noun form. Okay, so maybe like eating, walking could be converted into eat or walk. A runner, if you try to cut er, it doesn't convert into run, it converts into runn probably. So such errors can happen in stemmer, but stemmer is lightweight, okay, क्योंकि ये बहुत fast है, it is quick enough. ing मिल रहा है, ed मिल रहा है, program based है ये, cut कर दो. Whereas lemmatization, the other technique to reduce a word to a root form, uses dictionary, which is much more things to be loaded in the RAM. So But again, whatever we are building is not industry ready, so nothing will blow your systems through error memory. But we will use snowball stemmer for now, and this is the method in NLTK which will support English. So anything which is in English will be trimmed to the root form. Okay. So snowball stemmer is something we will be using to do it, and from NLTK dot corpus we will import stop words which we just downloaded, right? So this is how the things will work. I'll also mention here, this is the regular expression library. Okay, download the extension, activate or create stemmer method. Okay, we are storing it in a variable by the name of stemmer. It could be anything. Load stop words. Okay, now again we are dealing with strings, so we will have to import strings. Stop word could be now set. So again, if you are good with the theory of set, then understand it. The only thing between a difference between a list, which is something like this: one 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 two three four five six six, and a set of that list is the repetitions are not allowed. One two three four five six. Okay. So the double ones, double six go away. So we will create a list set of all the stop words dot words which are in English. Python is little you can say less rigid about the types of inverted that you use. Double or single, you can use any of them. Python will not mind that. Okay. Now NLTK stop words stemmer at your place. You have stop words right over there. Let me try to hit this import and see if things are downloading correctly. Downloading the package of stop words. It is installing from the internet. Okay, setting up it. Okay. Yes, Samir Dubey, you are perfectly correct about it. Okay. The last message I have is about buffer. Let me know if my internet capabilities are going down. Waiting for the download to finish. We will fix it. The words which are not in English. We will use regular expression to just simply move it around. We are just simply sticking it to English. So that should work. All right, it is done. So we are working with Collab notebooks, Jupyter notebooks. If you have the cell number like in 24 and in 25 printed, it means that the execution has finished. Okay, that's how you get to know. If you want to translate those words into English, so again, you will have to first build a strategy on to identify the language. Now, at a high level, told you it is Arabic, it could be Urdu, it could be Hebrew, or whatever you call it, whichever language it could be. Identify the language correctly. Use a translator. You can use maybe some paid APIs or open source APIs, maybe Google Translate. Maybe use your own machine learning model to translate them. Once you translate them, you will need a tagger to validate the translation is correct, right? Because I have worked around a lot of Arabic and Hebrew companies, like the projects, and trust me, the translate not always works like that, right? So, uh, especially like if you understand translate, it could work really in funny ways. For example, if I say something in English like "Baby, you rock my world," you convert it into Hindi, it won't be as pleasant as it sounds like. तुम मेरी दुनिया पत्थर कर रहे हो. Well, that's not exactly how the translation was supposed to work, right? So again, the idea would be that to solve such problem, you will need a good translation model and maybe some data resource, a human resource to validate someone who understands that language and English also for you, so that they can validate yes the translation is correct. If not, manual task will be needed over there. So with that in set, we will proceed. We will try to now create a function which can help us clean things. Now in Python, def is the syntax to initiate a function. Clean is something that I have personally written for me. It could be cleaner, it could be data cleaner, or whatever you want to call it, right? This is your choice. Something which goes inside the bracket is what you will take as input. My input would be text. Again, this is a variable name. You could call it anything. T, T1, X1, ABC, whatever you like, or even just a simple X. So so as a good developer, the idea is always to make sure the code is readable. If I write something like this, function f1 and input as t1, well, it basically puts any reader of this code into misery that they can never decode what I've written. Right? It is more like I'm writing in a coded language. So if I name my function from f1 to clean or a cleaner, it will make more sense, right? That it is supposed to clean something. And if I write text as the variable name, it will make more sense now that it is supposed to clean a text. Okay. Yeah. So ahead from it, if you say you want to work with text, so this is the string function that I'm using, which is so again I'll tell you why I am using string. Shouldn't this all the data points be in string itself? You can also try to print from d type, pandas data frame dot d types. Okay, you'll be able to get that some are object, and as we know that some are Hebrew languages, some are special characters. We will forcefully make the code more robust, that whatever the input first converted into string and in a lower format. Okay, so that we will also be able to work or handle the caps or the caps lock upper cases. Once that is done, what we would like to do is we would like to subtract certain things from our text. Okay, now I'll walk you around with all this the regular expressions that we will use over here. Okay, so these are some regular expressions that we will work. I'll walk you around through them one by one. Okay, one piece at a time. So if you look, the first regular expression tells you that anything that has a dot and question mark means an optional parameter. Like it could have something after dot also. We are not sure. Okay, how lengthy it could be, we are not sure. We were sure about the length. You would have mentioned over here, right? Maybe like uh, five things, four things, but we are not sure what could be after the dot. If it has something like that, just remove it. So that is the first parameter right over here, that what do you want to remove. And once you're removing it, what do you want to replace it with? I'm using an empty string. No, remember, not even a white space in between. Okay, not even a white space I'm adding over here. See, I'm removing everything, nothing in between, just remove it. Okay, and input is my text, so this is the input. So a regular expression will subtract this term or replace this term with something as empty string over there. Okay, so that's how you will be able to update the string. The next thing would be again to eliminate anything such as the hyperlinks like HTTPS. So again, if I have written question mark in front of the S, it means that S could be optional. This will handle now both. HTTP भी अगर लिखा है, HTTPS भी अगर लिखा है, both are what this regular expression will understand. अगर मैं P क्या भी question mark लिख दूं, it means P could also be optional. Okay. So this is what the question mark will do, followed by colon and slash slash. इसे आगे कुछ भी string में हो सकता है. Plus could be like we are not sure till where it to go. और ये जो vertical operator है, this is known as OR operator, right? So the OR operator is either you search HTTPS, अगर ये मिल रहा है तो चलेगा, ये नहीं तो www dot मिल रहा है तो भी चलेगा. ठीक है. Now why we are using a slash before dot is because we want to make sure that our regular expression understands कि dot भी as a string समझ रहा हूँ मैं वहां पे. तो slash dot makes it more rigid कि वो www dot होना चाहिए, उसके आगे कुछ भी string हो सकती है, वो स्ट्रिंग क्या है, कितनी है, मुझे नहीं पता, बट अगर स्ट्रिंग है उसके आगे www डॉट के आगे स्ट्रिंग है तो वो भी चलेगा, जस्ट रिमूव इट. ओके, then there are certain such things. Percentage s would mean maybe like some punctuation we are trying to escape, remove it. Slash n would mean next जो हम enter करते हैं वो slash n होता है. And similarly slash d would mean digits. Okay, things like that it could have. Just remove something like this. Okay, so these are certain regular expressions that we are trying to build and try to clean our text from. Okay, now I'll just uh, try to keep it like that. So now the next thing is that I would also now want to remove these stop words from this code. Okay. So let us proceed and I'll just explain you. This is known as list comprehension, probably to begin with, right? Word for word in. Okay, this is more like आपको यहाँ पे list comprehension एक बार short में समझा देता हूँ, ठीक है? Say example list is equals to maybe like example input is equals to 1 2 3 4 5. Okay, example input is equals to, yeah, this variable name is little way too big, I'll just call it e. Okay, or ex should also work. Ex dot split on, I'll be splitting on white spaces, and I'll print example for you. Now it is a list of individual strings, list of characters basically, right? 1 comma 2 comma 3 comma 5 like that. Okay, so now when I have to loop on it, say for I in ex, okay, print I. So how I'm writing it, this is two line. I can also print it like this. Okay, print x for or I for I in ex. So this also iterates like that, one by one iteration. This is how you write it in one single line. It is nothing but writing a for loop. Okay, that's what it means. So I for I in what text dot split, and I am just taking everything in one single line. See, so my input would be something like this, right? What my input could be, this is a great movie. Okay, so what I'm doing is for I in, or let me try to break it in baby steps. Okay, ex is equals to ex1 is equals to ex dot split on white space. Okay, now let me print you what ex1 looks like. See, this is what ex1 looks like, right? I have broken the string into individual form, right? Let me try to print x over here. Print ex is equals to comma ex comma slash in and comma, sorry, ex1 is equals to comma. So you see, this is your ex. This is a great movie. It is a single string, and ex1 is split of it. Okay. So remember, this is split, which means list of splitted string. Okay. Now when I do for I in ex1, print I. You can see this is how I'm iterating. This is a great movie. Okay. Or I can also use index for n comma I in enumerate ex1 print n comma, you will be able to see at which index which word is getting printed. Okay, so this entire piece of code, or let's keep it only I without using the index value. If you see, I am able to print one word at a time, and this thing can be shortened down by this list comprehension. I for I in text dot split. Okay, and then there's a condition to it. I can add a condition over here, right? If a word not is equals to stop word, something like that. Okay, so this is again written in one single line itself. I for I in text dot split. So remember, this is what you are using for iteration, and this is the for loop on the left. On the right is the if condition, which will go inside the for block like this. Okay, that if word not in stop word. So what is stop word? We imported it basically, right? We imported stop words, and that's how we are using it. And then we are stitching back by removing stop words. Okay. So this is the def function that I'll update with. Well, let me check if there are any issues. Anyone who is having difficulty understanding the code, or you think you are still not able to get something, you can understand. See, regular expressions I told you, slash d is digits, asterisk means and a length which is not defined, s is like string, question mark is like optional, the operator means or operator. Okay, if you want to add special characters, use slash before it. Okay, so I hope the insight till here is pretty clear that what exactly we are trying to do. Now the next thing would be that basically we will just go and data at title column. Okay, again we are using that title column only now. On that we are using a dot apply function. See, I have written dot apply over here. So this is again some smart way to do more code in less lines. Okay, rather than using a for loop and iterating each row in a column, and on each input using calling the clean function and then doing it, I am writing all this in one single line. Always remember, writing less number of lines doesn't reduce the complexity. Dot apply will automatically do that code for you. Code can never go short. Okay, writing 100 lines of code, but it is all steps are necessary, and writing 20 lines of code and using some libraries to do the steps doesn't necessarily mean that your line code is shorter, is faster or smarter, right? Of course it is smarter in a way that you are writing less code, but the code in itself will call some repeated lines of codes which are pre-built. It doesn't reduce the complexity. Okay, each for loop if loop still is executed. All right, so with that being said, I hope the idea till here is clear. All right, cool guys, I'll make sure that this goes into it. You can just quickly uh, write the code till here and we'll proceed then. Now let me just quickly check into your comments if possible. All right, so okay, so SP mentions that can you explain the third regex? So the third regex right over here. Okay, so you can see that the first operator, the less than operator, the opening angle bracket, it will try to match that. So we will be trying to remove any XML tags which start with this or end with this, right? Any zeros or dots which could exist in it. We are not sure over here. If you see dots could be there, could not be there, anything followed by the question mark laga diya hai. That's what we are doing, right? So plus operator would mean it will also match the preceding groups. एंगल ब्रैकेट्स जो प्रीसीड हो रहे हैं कहीं कहीं पे भी टेक्स्ट में मिल रहे हैं ना, इनको बस रिमूव कर दो, राइट? समथिंग व्हिच इज लाइक मोर लाइक एक्सएमएल टैग्स जैसे होते हैं. सो दैट कुड वर्क. ऑलराइट, सो HTML टैग्स भी होता है ना कई वाले, आपने देखा होगा. फॉर एग्जांपल कोई HTML देखा तो उसमें ऐसे टैग्स होते हैं, स्लैश p वुड मीन फॉर पैराग्राफ, है ना? और HTML टैग्स हो सकते हैं, XML टैग्स ऐसे. सो वी विल रिमूव ऑल सच थिंग्स अगर हमारे डेटा में एग्जिस्ट कर रही है एंगल ब्रैकेट्स के साथ. Okay, so again I told you like slash s would mean like it is a string and plus would mean preceding with it. Okay, so that's what that would do. Okay sir, I think your style of the animal hero, actually I get it a lot. Many people tell me, but I am also a hardcore Ranbir Kapoor fan. Luckily my hair length matches his current movie, so that works that way. All right, so I told you anything which is slashes is non-white character or whatever you want to take it. Plus, it means that the preceding element has to be non-white to it. That's what it would only mean. But again, I'll tell you guys, like understanding regular expression from a tutor, like how you're trying to understand these things, is just currently trying to satisfy your brain that okay, for now I got what is written over there. It doesn't actually help you learn regular expressions, right? I'll tell you that nowadays, since ChatGPT and Google Bard, these terms are readily available, they can explain you things much better than Geeks for Geeks or WCS School can do, right? For regex, especially. Try to play around with it. You can tell your Google Bard or ChatGPT to give you 100 or 10 or 20 interesting regular expressions as practice problems. Try to solve them. That will definitely help you out. Right. So right now, if you see in the cell number 38, we have uh, written the text over here, which is our clean function, and we have applied it on our database, right? So, well, that's how it's supposed to work. So it is pretty much straightforward. We are using one snowball stemmer algorithm. It is an algorithm predefined written code. You just need to import it and apply it. It will remove all the punctuations, HTML tags. जो third number के row में we are making sure URLs. Second number we are making sure new line characters. Here we are making sure stop words. जो भी हैं we are यहाँ पे अगर आप देख रहे हो punctuations we are removing it. We are applying stemming everywhere and we are just removing it, right? So now let us look at how does our new cleaned dataset look like. This was an explanation block. I'll just remove it. I'll say print data dot title. So remember, I'm using data frame. Data is my data frame, and dot title is the column name. And sample now again, as we have dot head, dot tail, we have dot sample, which would simply randomize few outputs for us. See, the index numbers are randomized. Again, if I will run it, it will be randomized, 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 randomized. Okay, sample would give me just 10 different samples of it. So if you see, like now the samples look pretty good, right? In fact, if I try to use just that title like this, we'll be able to see we still have some redundancies that we need to look into over it, right? But for now, the data looks pretty much more cleaner than we what were expecting it to be. Because I'll just go back to the title. This is the complete data set that I've printed. So title dot sample. Okay. So we can so again the idea of building something as close to Netflix cannot happen in 2 hours, right? Because if that was possible, thousands of companies and Netflix could come up in a day, right? So data cleaning is not simple task. Maybe like you'll have to look into whether what should I do with the full colon? Should I process question mark? Because many machine learning models, if you're planning to use, will be affected or will be sensitive to even colons or question marks, right? Even the apostrophes. You'll have to find a way to fix it then. Maybe just use some special keywords like replace question mark with uh, question itself, something like that, right? Or maybe use some XML tag them for those specific purposes. Okay, so that is most important thing that you will have to clean the titles from. Okay, similarly, if the since we are focusing more on genres, we are blessed that we do not need to worry more about titles for now because genres is something that will play a very crucial role for us. So I'll just go back, try to print data dot let me just check what are the columns that we have. Okay, okay, this is the column name genres. Okay, we will just use it. Yep, and this looks good. Interestingly, we have a lot of set of genres. So what makes a lot of set of genres is that a movie is not necessarily just one single thing. If we talk about the latest Ranveer Kapoor's movie, say Animal, it is not purely action, right? It is also a genre could be of say something like gore, which has a lot of violence in bloody manner, right? There's a lot of blood coming into the movie. So the genres could be action plus thriller. The movie is thriller, right? We do not know what happens in the end. There is always a thrill. The movie could be rated as adult because of the I'm not sure. Yeah, but because of gore or the violence and the language, it could go there. So genres could be multiple for a single movie also, right? So that could be the thing. Now the idea is that for one particular movie, which is say comedy, and it is a movie, so we will try to match with cosine similarity the genres which map most with it, right? So for I'll just try to quickly give you one example over here, that in this genre, if I print, okay, 0 to 100. Okay, so all right. Now, if you see, there are certain movies which go like this, right? Say romantic movies, okay? Or you can have something like horror movies, okay? So horror movies and international movies, this is one single string together, right? It will not exactly match more with just horror movie or just international movie. It will match more with strings which have this complete terms, right? For example, row number 95 will map or match more with something like row number 96. Okay, if you look at row number 97, it is just movies. So these two rows, they will match 100% cosine similarity. Okay, if you look at the next row number 98, even row number 98 will map a lot with 95, 96 because many terms are common in it. See, comedy is not there. 95, 96 is drama, but many words, many like the way the spaces are there, family, movies, children, and romantic, these words are common. Hence, cosine similarity will give you a much more match over there, right? Rather than just mapping row number 98 with 94 because it is a comedy, it will not work that way. Cosine similarity works how strings are much more uh, same in each other, right? In terms of the character level. So again, we will be using two important terms in order to build the model now. Okay. So those important terms would be term frequency, inverse document frequency, which is TF-IDF. I'll explain you this right now, and then the cosine similarity, which I just quickly explained you right now. Okay. So term frequency, inverse document frequency means it is a way of understanding how important that word is. Okay. For example, uh, if I tell you that my dog is always exasperated on the neighbor's dog, so this word is very new to you, right? Maybe it could be, and it word is very rare in usage, right? Maybe people will just simply say angry. Exasperated could mean something like that. So angry is a common term, right? Maybe like how do we call it? Someone who is weak with English, or someone who not even just weak, someone who is perfect with English but less on vocabulary would say, "Is this water? Has someone drink from this glass? Okay, or, is this glass stale or something like that? I don't know what English you will make, but someone might say, is this glass sipped? Okay, so this word sipped is rare. That out of 100, maybe 10 people, 5 people will call it like that. So exasperated or words like this, okay, they are very rare compared to words like angry, okay, because they mean same things. So in order to find which are the rare words, if you are able to find rare words, you will be able to mostly work around with your say sentiment analysis or recommendation tasks, right? Because in any review, stop words do not matter, right? For example, I'll tell you one simple thing, right? Say in any review, what are the chances of finding the word the? What are the chances of finding the word a, if, or, okay, things like this? They're very common terms. Mostly, many sentences will have it, okay, in, out, on, things like the prepositions, conjunctions, they will be there. But things like liked the movie, great movie, phenomenal, these are the words which will be rare available in the um, entire document. Now, when we talk about document, we talk about the complete data. In your data, there will be words which are less frequently used and words which are more frequently used. We want to focus on the words which are less frequently used, like phenomenal, great, amazing, nice, good movie, not good movie, bad movie, worst movie, rather than if, I, or the, in, on, top, right? These are the words. So how term frequency, inverse document frequency work is that imagine that your data set is like a book, a textbook would be. Okay. Now, the idea is that on the page that I'm currently on, maybe you can imagine the current review that you are looking into, the current movie review. If you find certain word, say one single word, you will try to find how much that word is repeated, how commonly or how frequently that word is available in that sentence compared to the availability of that word in the entire data set. And that's how you will find not only the importance of that word in this current review, but in the context of the entire data that you have, how common or less common that word is. So that's how TF-IDF vectorizers will work. It will convert your data set into vector form and try to find the common and the less common vector, right? So we will create an instance of TF-IDF vectorizer, okay? So again, basically what we will have to do is we will have to make sure that we will only pass English terms over here. So TF-IDF is the variable name that I create. TF-IDF vectorize is something that I've imported right now from feature extraction. Stock words I'm passing it to be English. Okay. Now we will fit this method on our data set. Okay, so that is known as fit and transform. So let us do that. So we will be using fit and transform the vectorizer on our data set. So TF-IDF matrix. Now remember, now after fit and transform, your input is or your current value is no more string. We have converted that into vectors, right? So vectors is nothing but again a very important concept. So many students who ask me particularly that what is the first thing that I should begin to learn data science, I will say that go for vectors first. Without vectors, you cannot fit a single day into the life of data scientist, right? So I'll make sure that you guys work around it if you are connected with me somehow, because that's the way I like to teach. I like to go with things which are most needed, right? I might forgive you for 10 different things like permutation combination नहीं आता चलेगा, probability नहीं आता चलेगा, फिलहाल साइड में रखो. When time comes, we will do it. First, vectors का concept कर लो अच्छे से, because with it many things will become easy for you in the terms of data science. Similarity. Now we will compute the cosine similarity of the matrix that we just created, right? So again, I told you we are using cosine similarity, right? That's something that we have imported. And to find cosine similarity, we will need to pass this matrix that we have created so that we have a similarity matrix available with us. I'll just try to hit it. TF-IDF vectorizer is not defined. Okay. TF-IDF vectorizer. Okay, I forgot to run the cell before it. And now if I run it, now the name feature is not defined. Okay, and okay, TF-IDF vectorizer. Okay. This is my bad. Basically, I just forgot to create the features in the very first place, which is the genre, right? We are talking about. So I'll have to create features over here first. Okay, so feature should be it comes from the data itself. We have data on genres. If I remember correctly, the column name is okay. We will see it if it errors out. If it has S or not, I'm not sure. Okay, dot to and yes, it works. So the genres we are converting it into vectors, and in terms of similarity, we are mapping it, right? So I hope you guys have understood the concept that what exactly a vector is supposed to be. If you have not, do not worry. I'll just simply for now try to explain you in short what vectors should mean. So when I create a graph x and y axis, I place a dot over it, right? Now this dot, where I'm placing it, if I have to locate it, I will need two important inputs: the address of that graph, right, in that space, but a 2D space where that vector is. I'll need the x coordinate and y coordinate. If I have these two coordinates, I will definitely reach that dot. So converting things into vectors makes it easy because everything comes on a single page, and everything we can be compared now with Euclidean distances or cosine similarities. They work on vector data set, right? You'll be able to use scale on graph and see it is 10 centimeter away, it is 3 centimeter away. So 3 centimeter away is more nearer than 10 centimeter away dot. So when all dots are on vectors, we can use scale and measure the distances of words from each other. And how they are placed on the graph in the first place? They are placed using TF-IDF vectorizer, where garbage things are placed together, rare things are placed together, and cosine similarity. will map all of their distances together in itself, right? So basically, that's how this system is supposed to work. Now, I'll just quickly walk you through the Netflix recommendation system. Okay, we will just create the function now. See, we are all set. We have similarity uh, right over here. The variable is similarity we have created, right? Now we just need to create our Netflix recommendation system, right? I'll say Netflix recommendation system. I'll create a function which will do it. Now you just give me a title. You give me a title what you're watching, and I'll take similarity as what I have created. Similarity is equals to my variable similarity. Okay. Once I have it, I'll just find that title from the index level. What I have, I'll just quickly explain you this how it's supposed to work. So I'll take the index from the indices of the title where it's supposed to be. Similarity score is something that I will create using my similarity. I'll just pass the index of the title where the title is in the vector form. Okay, in the vector form, I'll take see I'll explain you everything in one by one go. See, the function name is Netflix recommendation, and title is the input you are taking from the user. This is what actual user will give you. Similarity, you're using the vector database that you have created, right? The similarity, the Cosine similarity db that you have created for yourself, right? And you will find it through the indices of the title where in that this index is supposed to be. Map it in the similarity matrix that you have. Once you have it, you will have say 10, 20, 30, or whatever matching possibilities you have. The idea is not just to recommend you something which is similar, but recommend you something which is the most similar, right? I could suppose if I'm watching an action movie, there could be 100 different action movies which fall into the genre of action, but something which has the highest score should be suggested first, which is where the next line sorted will come into picture. We will be sorting the similarity score, and the key would be in the reverse fashion. Like we need the top priority first, okay? Not ascending, we need descending. That's why we'll use reverse equals to true. Something with the highest value should be presented first, and we will use 0 to 10, maybe at least 10 movies to the max we will recommend, right? Now this also depends upon the company or the business owners how they want to design it. See, Netflix, if you look into their you can say the UI, how it feels like, they have like 5, 10, 20, 30, how many, but they have a limit to recommend it one go, right? Maybe when you click on next button, the pagination loads some more uh, recommendations, right? So this is something which is a hyperparameter. You can decide how many in one go should I recommend, okay? And this is how you will return the data. From your data you will find the indexes and return the titles. Now, rather than returning the vectors, you will go to your database. You will locate the movie indices where exactly these indices are in your database, and you will not return the genres, you will return title of that index, okay? So we will just simply try to use maybe this is the function that will create. Now let me see some movies that are available, okay? Print data. Okay, so or maybe like we will try to say I will use any movie, something maybe like Alive. Okay, let me try to use Alive. Alive is a movie. Suppose I'm watching it. Print. What is the function that you have created? Netflix recommendation. We need Alive. We are watching Alive and recommend something similar to it. Okay. Name indices is not defined. So again, we must have missed creating the indices. Again, my bad. Let me just quickly check and fix this. Okay. Where I've created the similarities, just let me quickly go to it. Yep, similarities go right over here. And I'll have to create something known as indices, which will be nothing but the indexes of the data itself, right? So I'll use data.index and index from the titles. I'll drop the titles duplicate and I'll find the indices that. Okay. So indices will be nothing but the ways to find the row number. Okay. And once I have it, it should work in that terms. Again, let us look whatever it is. Key error. The above exception is because key error. Let us try to check. Maybe this alive doesn't exist correctly in the data frame. Okay. Missing one position argument title, and now let us pass one title. Next one, double that called the exception. All right. Let us say we will use title is equals to. Okay. Mhm. No, vectors not in terms of physics, vector in terms of mathematics. Okay, got it. We are using title, but we are finding indices on based on title, right? And indices of title is something that should still work. Hmm. Okay. So the error is right over here in the indices. Did we update it? Similarity is cosine similarity of TF-IDF matrix and the dot index is equals to this and this. Okay, this is what the indices are supposed to be. Let me print indices. Okay, this is how the indices work. So if I have to print indices at say hashtag alive, it should work that way. Alright. So it still requires a little more cleaning, but we will try to just proceed with it. Let me do Netflix recommendation for hashtag alive. Okay, hashtag alive, and this is how it will work. So the idea is that our database currently needs a little bit of more cleaning. That of course is the idea that I told in the very start. We'll have to minimize the processing task and keep it more like an open challenge for you that you can further improvise it. Now suppose if I do not have something like say mostly this data set will not have something like tiger 3. Okay, so which is where it will say key error. Okay, and maybe you can raise an exception over there, right? You can create try and accept block for it. Okay, we'll say print not in database. So rather than getting that error, now you will get tiger 3 is not in database. Okay, so we cannot recommend you movies similar to tiger 3 because they are not in our database, as simple as that. Okay, so which is where the idea would be that your code will be more robust in these functions, and your code, if it matches a movie, it will be able to recommend the next movies. For example, if I do hashtag alive, it should give me more movies like that. Okay. So Game Over in three versions, which is again Hindi, Tamil, Telugu. So you see, Game Over seems to be a very good match with the Alive movie. But the idea is that again now the next step from here, suppose assuming that you have pre-processed your data correctly and you're now on a point that you are getting movies even in different languages, could be a next further problem to solve, right? That let's not recommend same movie in three different languages, right? Rather than recommend it one and say it is available in languages. And if you look at Andha Gharam and Andha Karam, I'm not sure if these movies could be same. You can look into it, right? So the idea of building something like this will always remain open until unless you refine it to a level that it becomes something like a product, right? But the goal of this 2 hours of session was to walk you around and explain you the different type of recommendation systems, what they are, how do they work, how can we make something like that, and now you have a core functional foundation of how a content-based recommendation system can be made. You can simply use a cosine similarity. You can try to work around with the parameters and things like that. Can you get the source code? Yep. So let me definitely try to save this file. Let me try to download this. Okay, this one seems to be correct. Let me just once stop my screen sharing because I'm not sure if that is causing problem. My save button is not working correctly. Now it is working. So save as I will save is as a notebook file, and let me check if I can attach things. Okay, now present slides. Okay, so just I'll quickly go to my drive and I'll upload the notebook over there. So meanwhile, let me know how was the session in which you guys did you learn something? Was it insightful? What things could have been better? What should we do next? If you need more live sessions, what should those live sessions be on? You can also try to recommend us. We definitely will look into it and try to see if we can arrange sessions for you about the same. So by the date modified, I'll take a recommendation system. Let me upload it. All right, the file is uploaded. Let me share this file. Share, copy link, share. Let me change the availability of it. Anyone with the link is editor for now. So copy link, StreamYard, I'll paste it. I'll also recommend if the moderators can share this with you. So yeah, although I'm trying it myself. Sure. Yes, so Let's Upgrade have shared the resource with you. You can open this link and please, guys, try to maintain the you can say professionalism. I have given you all the access to it. Do not just simply go ahead and delete the file from there. Let anyone who wants have the file over there, right? Just download the file. Never try to delete it because yeah, that should be all. Now, is there any doubts that we can handle? Okay. Yeah. Let us check live session. So it was great. It was fun having you all. Thank you so much, Amrit. And with that, we can conclude. Yep, we are done with the session. Thank you so much for bearing me for these 2 hours. It was really interesting to have you all live. I look forward to see you all next time. All right. Thank you so much. Bye, everyone.